Introduction to Archimedes' principle. We have discussed the buoyancy or upthrust force in our previous topic. Do all the objects experience the same quantity of upthrust? For instance, if a stone, wood, and an iron bar are placed over a water body, do they experience the same upthrust force, or the buoyant force? It was answered by a Greek scientist called Archimedes. He discovered it when the water in his bathtub overflowed when he stepped in it. With this knowledge, he discovered and stated that, whenever an object is partially or fully immersed in a fluid, the buoyant force, or the upthrust force, is equal to the weight of the fluid displaced by it. This is named Archimedes' principle. This principle is applied in the design of air balloons, ships, submarines, etc. In this lesson, we are going to discuss it in detail, and at the end of this session, you will be able to describe Archimedes' principle and solve a problem based on Archimedes' principle. Experiment on Archimedes' principle. Let's discuss Archimedes' principle used to measure the buoyant force, which is the weight of the fluid displaced. Materials required are a spring balance, a measuring cylinder, a beaker with water, and any object. It is to be noted that the object should be heavier than water. So a metal bob is taken here. And finally, a string of negligible weight. First, we should confirm the initial reading of the spring balance to be 0. Then metal bob is tied with the string to the hook of the spring balance. Then we have to pour some water into the measuring cylinder. The initial volume of water is noted to be VI, here it is 40 milliliters. Now, we have to suspend the metal bob carefully into the measuring cylinder with water. You can notice the water level rising in the measuring cylinder. Notice the final reading and let it be VF here, it is 60 milliliters. Let's table the values found. And from these values, we can calculate the volume of the water displaced to be 20 milliliters. Let's table the initial and final weights of the spring balance. From these values, we can calculate the weight of the metal bob to be 400, and its unit is Newton. According to Archimedes' principle, whenever an object is partially or fully immersed in a fluid, the buoyant force or the upthrust force is equal to the weight of the fluid displaced by it. Problem based on Archimedes' principle. This Archimedes' principle is also used to find the density of any object. Let's see how. We have already calculated the weight of the metal bob to be 400 Newton. From this, we can calculate the mass of the metal bob by dividing the weight by the gravitational value. And it is found to be 40.8 grams. We have also calculated the volume of water displaced. Thus the volume of the metal bob obtained is 20 milliliters. From the known values of mass and volume, the density of the metal bob can be easily calculated. By substituting, the density of the metal bob is found to be 2.04 grams per centimeter cube. Conclusion? So, we learned about Archimedes' principle, and also seen an experiment, and solved a problem based on Archimedes' principle. Summary. From this lesson, you have learned Archimedes' principle, which states that, whenever an object is partially or fully immersed in a fluid, the buoyant force or the upthrust force is equal to the weight of the fluid displaced by it. Archimedes' principle is applied in the design of air balloons, ships, submarines, etc. Archimedes' principle is also used to find the density of any object. And the density of an object equals its total mass divided by its total volume.